Light painting is a photography technique, in which light sources are moved in specific patterns, while being captured by long exposure. The technique has been used by many artists, photographers, and scientists. In conventional light paintings, the light sources are usually flashlights or other simple handheld lights made by attaching one or multiple LEDs to a stick or a ring. The patterns created are limited to abstract shapes or freehand strokes. A similar long exposure technique, called kinetic photography, can also create abstract and artistic light patterns. The camera is moved or thrown into the air, while its shutter opens. We mount a flat display to a 6-axis robot arm to sweep a display volume, and place a stationary camera at an arbitrary position. We display the chessboard pattern on screen and use robotic hand-eye calibration method to precisely obtain the transformation from the robot to the display. The camera pose will also be determined at the same time. The display shows real-time rendered image sequences that are synchronized with the robot motion. The images are some contours representing the cross-section profiles of a virtual object that is sliced at arbitrary positions and orientations. All light contours are captured in the long exposure and constitute the virtual 3D object augmented in the real space. Similar to a volumetric 3D display, the 3D imagery can be captured from many different angles. We propose a new slicing method by organizing the triangular mesh into octree data structure. The approach can significantly reduce the computational time and improve the performance of real-time rendering. We also implement texture mapping to produce colored light painting. Our computational light painting methodologies can also be applied to computational kinetic photography, as they are dual problems. Instead of keeping the camera stationary, we mount the camera on the robot arm to take long exposure during move. The camera captures the light contours shown on a fixed display. After calibration, we transform the display path for light painting to the camera path for kinetic photography, while keeping the same set of relative poses between the camera and display. This work provides a computational framework for creating swept volume light painting and kinetic photography. Apart from robot, other pose estimation methods, such as mocap, or IMU-based motion tracking, can also be used. Thank you for watching.